Okay, so I'm going to cut y'all a little bit of slack. I cut the notes down. I had a longer video for y'all, but I decided I would cut it down a little bit. So we're actually going to cover four main things. We're going to talk about properties of trapezoids and kites. So we're going to look at non-isosceles trapezoids, isosceles trapezoids, mid-segment of a trapezoid, which is very similar to the mid-segment of a triangle. And then we're going to look at the properties of kites. And I saw that a lot of you didn't know that a kite was actually a shape. So it is more than just something that you can go fly on a windy day. All right, so let's go ahead and get these filled out. All right, so we have a quadrilateral with exactly one pair of parallel sides. It's a trapezoid, okay? So the definition of a non-isosceles trapezoid. So it might look something like this, where you just have one pair of parallel sides. So the parallel sides are called your bases. And I'm going to try to get this where you guys can actually read it. And the bases are the two sides that are parallel. So I would say that EF is parallel to HG. The non-parallel sides, these are, first of all, they're not congruent. So the non-parallel sides are not congruent. So maybe make yourself a note that they're not congruent. And point at this right here. So the non-parallel sides are not congruent. These are called your legs. So I would say that EH and FG are my legs. So notice here I put they were parallel. Here I'm just stating two pieces. I have two pair of consecutive interior angles, or two pair of same side interior angles. So remember that the consecutive interior angles are equal to 180. And that's going to be these two. So I would say angle E plus angle H equals 180. And then these two over here would be same side interior. So I'd say angle F plus angle G also equals 180. But unlike parallelograms, these two are not. So you only have two pair instead of four. So now using these properties, let's just do some basic stuff. So first of all, I see that I have one pair of parallel sides. So that means I have a trapezoid. So that means these two angles are going to add up to 180. And these two angles are going to add up to 180. So if I did 180 minus 87, I'm going to get 93. So this angle is 93 degrees. So angle M is 93 degrees. And that makes this pen a little smaller. Okay. And then I would do 180 minus 51, and I get 129. So this angle is 129. So that's using this last rule, two pair of consecutive interior angles. Here, the same thing. I see I have one pair of parallel sides. So therefore, these two angles are congruent. Sorry, not congruent, supplementary. So we got 180 minus 31. So that is going to be 149 degrees. So angle C is 149 degrees. And then we will look at these two on this side. Sorry. So this is going to be 180 minus 62. So that's going to be 118. So this angle is 118. So as you see, they're clearly not supplementary or congruent. They're at the bottom. So it's also going to work if you have algebraic expressions instead of just plain old numbers. So just like when they're plain old numbers, it's really easy because you're just like, okay, I'm just going to subtract this from 180 and what's left over is my answer. But when I give you an algebraic expression, you physically have to add them together and set them equal to 180. So if I did 12x plus 7x, that's 19x. And then 3 minus 13 is negative 10. And that equals 180. So I would do 19x, add 10 to both sides. So add the 10 over here. Now I have 190. And now divide by 19. So x goes in, or 19 goes in 10 times. So now that I know what x is, I can plug it in because they want me to find the measure of this angle O. So 7 times 10 minus 13. So that's 70 minus 13. So that would be 57. So angle O is 57 degrees. All right. So now let's get a little more specific and let's talk about isosceles trapezoids. So in an isosceles trapezoid, well, real quick, let me just go back for 1 second. Make sure that you know that these are your bases. So when you're looking at this, this is your base, and this is your base. This is a leg. This is a leg. And then these are your base angle, or these are your consecutive angles, and these are your consecutive angles. So make sure that you have that piece, because when you get into an isosceles trapezoid, there's a few more properties. These are still, your bases are still parallel, so you still have your parallel bases. So base 1 and base 2. But this time your legs are congruent. So this time your legs are congruent. A minute ago they were not because it wasn't isosceles. So this time my legs are equal. Just like an isosceles triangle has congruent legs, an isosceles trapezoid does too. And the diagonals are congruent. So I would say that AC is congruent to DB. Here I go up here and say the legs, AB is congruent to CD. So you have a little bit more stuff that's congruent. And then this time we have base angles. So like this base angle is congruent to this base angle. So I would say angle BAD is congruent to CDA. And the same is true at the top. So I would say angle ABC is congruent to DCB. So this time you got some angles that are equal. You got some diagonals that are equal. You just have a little bit more that's equal all the way around. All right. So using those properties, let's do some isosceles stuff. So first thing, when you see the little tick marks here saying, hey, these guys right here, these two legs are equal, that means if this angle is 23, that means this angle down here is also 23 automatically. There's no math to be done. It's just automatic. Base angles are congruent. These two angles are still supplementary. So I can still do the 180 minus 23. If I want to do 180 minus 23, I get 157. So angle K and angle J are 157 degrees. It's going to work the same way whenever you have your isosceles trapezoid in algebra. It's going to work the same. So we're going to go through and we're going to look at, okay, so AD is congruent to BC. So AD is congruent to BC. So let's go ahead and set that up. 16x minus 13 is equal to 9x plus 8. So if I subtract 9x from both sides, so if I subtract 9x, I get 7x. And if I add 13, I get 21. So 7x is equal to 21, so x is 3. And it just says to find x. It didn't tell me I had to plug it back in. So there's part of my answer. And then the other part is dB. Well, dB is a diagonal. So this diagonal is equal to AC, which is your other diagonal. So I've got, let's scroll down here. So I've got 12y minus 37 is equal to 5y plus 19. So I'm going to subtract this 5y. So I get 7y. I'm going to add that 37. So now if you look at it, you got 19 plus 37. So that's 40, 55, 56. So that's equal to 56. So 7y equals 56. So that means y is 8 because 7 times 8 is 56. So there is your two answers for those. The next piece we're going to look at is midsegments. Midsegment of a triangle. Remember, it was half the base. Same thing for a trapezoid. It's still going to be half the base, but there's two bases. So you just add them together and take half the sum. So it's half the sum of your bases. So what that's going to look like is the midsegment of trapezoid is MN. Okay? And it is parallel to the top and the bottom. So I would say AB is parallel to MN, which is parallel to DC. The formula, MN is half of AB plus DC. In other words, the fastest way to write this, we'll call this M, we'll call this B1, and we'll call this B2. So you could say that the midsegment is half of base 1 plus base 2. Or you could say two midsegments, so 2 M's is equal to B1 plus B2. Depending on what I give you, honestly, will kind of determine which one's easier to use. So if you're looking for this, add and divide by 2. If you know this, then you want to do this one. So let's look at what we got here. So I'm looking for this. So I'm going to call this X. So if I'm looking for the midsegment, then I know that the midsegment is half of base 1 plus base 2. So obviously, when I just give you numbers, y'all know that part's always easier. It's when we get into number 8 is where y'all start getting confused. So half of 48 is 24. So CD is 24. In other words, this number needs to be just slap dab in the middle of 12 and 36. So this side is 24. I'm going to call this X this time. So remember I told y'all if you know this one to double it. So that would be 2 times 1.8 is equal to X plus 0.6. So if you double the middle, you can kind of work backwards. So 1.8 is 3.6, or 1.8 times 2, sorry. And that's X plus 6. Subtract your 0.6. And I get 3 is equal to X. So that means this side is 3. So if you took 3 plus 0.6, you get 3.6, and then half is 1.8. So let's try the last one. So since I don't know any of it, I'm just going to think, okay, what have I got? I'm going to take the midsegment, which is 3x minus 2. 3x minus 2. And it's equal to half. And then add the rest. X plus 11 plus 3x plus 3. So we wrote it all out. So we get 3x minus 2 is equal to half 4x plus 14. X plus 3x is 4x. 11 plus 3 is 14. So 3x minus 2. So half of 4x is 2x. Half of 14 is 7. So now it looks a little more normal. So I'm going to subtract 2x from both sides. So that's gone. That gives me x. And I'm going to add this 2 to this side. So x is 9. But what are they asking me to find? They're asking me to find EH, which is this piece here. So 3 times 9 plus 3. Well, what's 3 times 9? 27. 27 plus 3 is 30. So this is 30. And if you plugged in 9 here, 9 plus 11 is 20. 20 plus 30 is 50. Half of 50 is 25. So if you wanted to get all the sides, depending on what they ask you, then you would just plug x back in real quick and get the rest. All right, our last part. Now we're going to talk about kites. So first off, it is a quadrilateral. It is not a parallelogram. Not a parallelogram. It is just a quadrilateral. So the cool thing about the quadrilateral, the diagonals are perpendicular, just like a rhombus. Okay, so if you go over here, if you were to draw your diagonals, I'm surprised these lines are even halfway straight. So the diagonals are perpendicular. That means it's 90 degrees in the center, just like a square, just like a rhombus. So I'm going to say that CA is perpendicular to BD. I have 2 pair of consecutive congruent sides. So instead of the opposite sides, these 2 are going to be congruent. So CB is congruent to BA and the bottom part. So CD is congruent to AD. And there's exactly 1 pair of opposite angles that are congruent. So you look at the angles that's between the 2 different sides, not the angles that are between the same sides, but the different. Those 2 are going to be the ones that are congruent. So I'm going to say that angle C is congruent to, angle A. So angle C is congruent to angle A. But I will tell you this, the diagonal that runs through here, it splits the entire kite in half. So like this angle is going to equal this one, and that one's going to equal that one. So it splits the whole thing in half. So given that this is a kite, then I'm going to say that AC is perpendicular to BD. And if BC is congruent to BA, then BCD, see if I can squeeze this in here. So BCD is congruent to BAD. And angle CBA, I should have, CBA, so that would be the end, is not congruent to the other end. So CBA is not congruent to CDA. So do you see any congruent triangles? So basically what's going to happen here is you're going to have this little triangle congruent to this one. You're going to have this triangle congruent to this one. You have some isosceles triangles. There's a lot of congruence still going on. It's just you have to really look for it. So let's call this point of intersection E. So I'm going to say triangle CBE is congruent to triangle ABE, and triangle CED is congruent to triangle AED. All right, so let's knock out these examples. So since this is equal to this, then that means that running through here is going to be a bisector. That splits this whole kite into 2 equal pieces. So this angle is equal to this angle. So if this angle is 90 and I just cut it in half, that means each piece is 45. And this whole angle was 130 and I just cut it in half. So that makes each piece 65. If I know 2 angles, what's 65 and 45? So 65 and 45, so 65 plus 45 is 110. So that means this has to be 70. So 180 minus 110 is 70. So now I know that this is 70, therefore this is 70, because those two angles are your congruent angles, because this is your bisector. In number 10, automatically draw your right angles there. This piece is going to be equal to this piece. Okay, remember this longer piece is going to be your bisector. So that means that 1 over 10x minus 1 is equal to 9. So we're just going to find x. So the first thing I'm going to do is add the 1. So I get 1 over 10x equals 10. Don't forget, when you're multiplying by a fraction, if you multiply by the reciprocal when you're solving, it'll cancel out. So that means x is 100. So x is 100. And our last example, I feel like I'm going to change colors here. I feel like I'm going to run into this. Okay, so automatically I always go in and put a right angle at the center because they're perpendicular. That is a fact. This piece right here is equal to this piece. This piece is equal to this piece. And that one is equal to that one. Those are guaranteed every time, okay? So first thing I noticed that if this is 90, I know this is 90 on this side. So do you see this little triangle right here? Here, let me use a highlighter. Let me do it this way. Do you see this triangle? I'll make it yellow. Okay, that triangle right there, see how you know two sides? Well, before y'all ever came into geometry, y'all already learned Pythagorean theorem. So anytime you have a right triangle, you can use Pythagorean theorem. So if I did 6 squared plus 8 squared, and then took the square root, that is going to give me the length of WZ. So that's going to be 36 plus 64, which is 100. So the square root of 100 is 10. So that makes this part 10. Therefore, this part is also 10. And that's how it's done. So I will see y'all in class, and make sure you get everything taken care of before you come. See you then.